Now let's switch our focus to refraction. Here we have medium 1 and medium 2, and this is the interface between the medium. This is a ray which is coming from here and meeting here at point O, which is point of incidence, and getting reflected like this. Let's say it is coming at an angle alpha, which is angle of incidence, and let's define after refraction it is going at angle beta from the normal, called angle of refraction. Let's try and set up some experiment and find the relationship between alpha and beta and establish law of refraction like we did for the law of reflection. Snells in the late 17th century formulated such law by observing these light rays at different angle in this setup. So here we have medium 1 here, medium 2 here, and this is the interface between the two medium. Let's call it air and water. Here ray number 1 is coming at angle of incidence alpha 1 and getting reflected at angle of incidence angle of refraction beta 1. Here ray number 2 is coming at angle of incidence alpha 2 getting reflected at angle beta 2. Similarly, this ray is coming at angle of incidence alpha 3 and getting reflected at angle beta 3. Now, in order to find a relationship between these angles, let's draw a perpendicular at any chosen point F like this GF. This ray from O to A1, wherever it is meeting, let's call it point A1, and let's draw the extension of this ray without refraction in a straight line coming like this and meeting at P1. Similarly, for the ray 2, after refraction it is coming at A2, and without refraction let's assume it would have come to B2, and A3, which is coming like this, getting reflected here and without refraction in a straight line to B3. Snells, by doing lot of experiment on these angles, find that OA1 divided by OB1 is equal to OA2 divided by OB2, OA3 divided by OB3 is equal to constant. So doesn't matter which ray we are considering, this ratio remains constant. So we can write a general law like OAI divided by OBI is equal to some constant. Now observe this. This is the angle of incidence alpha 1 and this ray is getting reflected at beta 1. Now this beta 1, this angle here will be also beta 1 because these lines are parallel. So we can simply write OA1 sine beta 1 will be equal to OF in this triangle. Similarly, this is angle of incidence alpha 1 without refraction, this ray is coming like this. So this angle here will be equal to alpha 1, and because these are parallel, this will be also equal to alpha 1, and hence we can write OB1 sine alpha 1 is equal to OF. Now if we take the ratio, we basically can see that sine alpha 1 by sine beta 1 is equal to constant, or in a general form we can say that sine alpha by sine beta is constant. This is the law of refraction by Snells. This is the expression for Snell's law. We'll write this law in different format so that we can use it in our problems and try to understand geometrical optics better. But before that, let's move to something called Huygens principle.